Hello, my name is Daryl Shirley, and this is my Physics Lab 2. Introduction. In this lab, I will be going over the purpose, main ideas, fundamental physics principles, system and surroundings, preview, models, possible errors, questions, and conclusions. Purpose. The purpose of this lab is to create a computational model of the experiment we conducted in Lab 1. In Lab 1, we sought to measure the charge of a charged piece of Scotch tape floating above another charged piece of Scotch tape. The difference between this computational model and the previous model in Lab 1 is that we will no longer be treating the floating piece of Scotch tape as a point charge, but as a set of multiple charges to better resemble what's actually going on. Main ideas. The main idea of this lab is that we are trying to create a computational model that estimates the magnitude of the charge evenly distributed along the length of the floating piece of Scotch tape. Fundamental physics principles. The fundamental physics principles being used in this lab are Coulomb's law, the equation for finding the electric field, and the acceleration of the force of gravity close to Earth, 9.81 meters per second squared. System and surroundings. For this lab, the system will be the set of charges representing the floating piece of Scotch tape, which you will see in the computational model are the red balls. The surroundings are the set of charges representing the bottom piece of Scotch tape, which you will see in the computational model are the blue balls, and the Earth's gravity. Preconditions. The preconditions of the lab are listed below. The mass of the piece of Scotch tape, the acceleration due to gravity, the K constant, and the electric field equation K times Q times R hat divided by R max squared. Preview. During this lab, a computational model will be created depicting the charges of the tape and the direction of the E field and forces acting on the tape. I will also answer the question of the lab, including, but not limited to, the what if and why questions. Computational model of the Scotch tape coding. For the coding of the computational model, I had the preconditions for the K constant, the mass, acceleration due to gravity, and the electric field equation on the left. On the right, I have the scales of the electric field, electric force, and gravitational force listed. Since the electric force and gravitational force are supposed to cancel each other out, the scales are equal as their forces are equal. On this page, you can see the for loop I used to calculate the electric field at each point on the floating piece of Scotch tape, as well as the creation of the arrows depicting the electric fields and the electric force and gravitational force. Here is my model of the tape. To the right is the model created from the coding. As you can see, the electric force in white has the same magnitude as the gravitational force in yellow. This shows that the two forces are indeed equal, thus canceling each other out so that the piece of Scotch tape can float. Errors and possible explanations. The potential errors that could have occurred during the creation of these models could have happened during calculations such as the inputting of wrong values. Questions. The magnitude of the charge on each piece of tape was calculated to be 4.47214. The assumptions I made to approximate the amount of charge on the floating tape were that I ignored the air resistance on a moving object and assumed that each piece of Scotch tape had about the same amount of charge evenly distributed along the length of the tape. What if? The estimated values of my charges for each computational model were slightly different. For Lab 2, the value was 1.6 times 10 to the negative 8, while for Lab 1 it was 1.8 times 10 to the negative 8 coulombs. If I had modeled my piece of Scotch tape like a single point charge, my estimates would have been different for several reasons. First, the electric fields displayed would have been depicted as a single field point pointing straight up like the net electric field instead of showing how the electric field at each point had a slightly different direction. The why question. For my computational model, the value that would most likely resemble real life would be Lab 2's computational model, since in real life the charges of a piece of Scotch tape would be evenly spread out along the length and not concentrated at the center. Conclusion. So in conclusion, this lab report went over the model I created depicting the piece of Scotch tape's charge evenly distributed along its length. It also shows the direction and magnitude of the forces and electric fields acting on a floating piece of tape. I answered the possible errors and what if/why questions. Thank you for watching.